In this video we're going to return to the topic of trigonometry, and specifically this time we're going to look at wave functions. And in this lesson we're going to focus on solving simultaneous equations. Now you are actually familiar with some wave functions, although you may never have referred to them as wave functions, and the ones you're most familiar with are the sine function and the cosine function. But we could actually add these functions together if we wanted, if they had the same period, to obtain the function sin x plus cos x. And that would look something like this. This is also a wave function. And you can see here hopefully that the amplitude has changed from the two separate graphs of sin x and cos x. So the amplitude has changed, and you can also see that there's been a phase shift as well. And as a result of both of these, we can actually express this wave function here in the following forms. So k multiplied by sine of x minus alpha. We could express it as k multiplied by sine of x plus alpha. K of cos of x minus alpha. Or k times cos x plus alpha. So we could express it in these four different forms. So during this topic, that's what we're going to learn how to do, and then we'll be able to solve equations from that and be able to sketch graphs and work out maximum and minimum values of these functions as well. So to start off, we're going to look at solving simultaneous equations, which involve trigonometric functions. So we're looking to solve simultaneous equations of the form k sin alpha equals a and k cos alpha equals b. So you can see that the two variables which are common to each of these equations are k and alpha. So that's what we're going to solve for here. So let's firstly look at solving for k. Now, you might be wondering here, how are we going to do that given your previous knowledge of simultaneous equations? But if we actually square each of the equations we have been given, so if we square k sine of alpha equals a, we will get k squared times sine squared of alpha equals a squared. And if we do the same to the second equation, which is k cos of alpha equals b, and if we square all of that equation, we will get k squared multiplied by cos squared of alpha equals b squared. And if we now add these equations together, we'll get k squared sine squared alpha plus k squared cos squared alpha equals a squared plus b squared. And you might notice on the left hand side here that we've got a common factor of k squared. So if we take the common factor out, we get k squared multiplied by sine squared of alpha plus cos squared of alpha, and that's equal to a squared plus b squared. And hopefully you will remember here that we've got a trigonometric identity here. Sine squared of alpha plus cos squared of alpha is equal to 1. So that tells us that k squared is equal to a squared plus b squared, and therefore k is equal to the square root of a squared plus b squared. Now we can now solve for alpha. So we will need to employ our cast diagram at this stage, but I'm not going to do this just now because I'm just looking at solving these simultaneous equations generally. So we will have different values for a and b normally when we're solving these equations, and that will affect the cast diagram. So let's look at the equations to solve for alpha. So if we divide the first equation by the second, so k sine of alpha over k cos of alpha is equal to a over b. Now the k's here will simplify to 1, so we'll be left with sine alpha over cos alpha equals a over b. And hopefully you remember the other trigonometric identity from National 5, sine alpha over cos alpha is equal to tan alpha. So that means that tan alpha is equal to a over b, and then we're able to solve alpha in terms of inverse tan. So we've seen how we can do this generally. Let's have a look at a specific example. So we want to solve the following for k greater than 0 and alpha lying between 0 and 360. So the equations are k sin alpha equals root 3 and k cos alpha equals 1. So our solution then, let's solve for k first. So remember, to solve for k we need to square both of our equations. So squaring the first equation will give us k squared multiplied by sin squared of alpha equals 3. Squaring the second equation will give us k squared times cos squared of alpha equals 1. And if we add these equations together, that's k squared times sin squared of alpha plus k squared times cos squared of alpha is equal to 3 plus 1. Now on the left hand side we can take out a common factor of k squared, and obviously on the right hand side we can evaluate that to get 4. So that gives us k squared multiplied by sin squared of alpha plus cos squared of alpha equals 4. And remember that trigonometric identity, sin squared alpha plus cos squared alpha is equal to 1. So k squared multiplied by 1 is equal to 4, which means that k is equal to 2. And we should remember, obviously k could be negative 2 as well, but it was stated up in the question that k had to be greater than 0, which will tend to be the case when we go through these wave function questions. So we've solved for k, that's one of our answers, and we need to find alpha now. So k sin of alpha over k cos of alpha is equal to root 3 over 1. And our k's will simplify to 1 here, which will leave us with sin alpha over cos alpha equals root 3. We know that sin alpha over cos alpha is equal to tan alpha. Now we can see that tan alpha here is positive, so we could assume that our answer would come in the CAS diagram from the first or the third quadrant, okay, but we actually need to check that in terms of the equations that we were given. So the first equation we were given was k sin of alpha equals root 3, okay, so we know that if sin is positive, the answers will either come from the first or second quadrant. And for k cos of alpha equals 1, that's positive as well, so our answer will either come from the first or the fourth quadrant. And we can see there the one that is common to both is the first quadrant. So alpha is equal to inverse tan of root 3, and that gives us 60 degrees. So just now it would be a good time to pause the video before the screen goes blank, copy these notes down, and make sure that you complete the assigned exercise for today.